Very good morning to all of you. Yesterday we saw one example with the connection problem. You started your lecture with the mobile and computer example. Every day of the lecture, half lecture is hampered due to the connectivity issue. But inshallah soon it will be uniform and complete the piece as as and when required. So this yesterday the unit half part we completed. Now today we will see the hydrostatics. Statics uh, is nothing but you can say the body at rest when it is solid body, but in case of fluid, at a fluid at rest, it's called as hydrostatic. In this, we learn the variation of pressure with depth of liquid. In this, we will learn the variation of pressure with the depth of liquid and the measurement of pressure and forces on immersed surface and the measurement of the pressure and the forces on the immersed surface. We will learn on the hydrostatics. So we have started the part B of unit number 1, that is the fluid static, or you can say the hydrostatic. So we will see the basic equation for a hydrostatic and the concept of pressure. Okay, so from this you can learn. This is from the book of I think so. Suresh Krande, and you can it is available in our library also. You can search and you can get it. So generally, when we will say the pressure or intensity of pressure at a point in a fluid is defined as the force exerted per unit area. So if you compare the stress with the pressure, you will come to know that they are nothing but the stress is nothing but load upon area. Here, if you define the pressure, is nothing but here P is the pressure. The pressure is nothing but force upon area. Force upon per unit area. Okay, so the force exerted per unit area is nothing but the pressure. Okay, जिसको हम लोग उर्दू में क्या बोलते हैं, उर्दू में हम बोलते हैं दबाव. हाँ, हम लोग कोई भी चीज को दबाते हैं तो उसका अगर वो इलास्टिक बॉडी है तो व्हाट हैपन, द इलास्टिक बॉडी इट changes its shape. And when we remove the force, when we remove the pressure, what happens? It will regain its original position. So what is the pressure? The force applied on the per unit area or force exerted on the per unit area is nothing but pressure. It always acts in a normal direction to the surface in contact. We will see the example that later on, and is compressive in nature. The force दबाव जो है वो ऑलवेज इट इज कॉम्प्रेसिव इन नेचर. हमको मालूम है कि हमारे कॉलम पे भी कॉम्प्रेशन फोर्स होता है, दबाव होता है, प्रेशर होता है. ओके, दैट्स व्हाई वी आर कॉलिंग एज ए कॉम्प्रेशन मेंबर टू द कॉलम. It always acts in a normal direction to surface in contact. Okay, so it is always act normal direction to the surface of contact. It means that the pressure always perpendicular to the surface of contact. So if you see the surface of contact here, you can see a sloping slope is there, this ground is there, and you see this is the water or any fluid, and if you this force, it will act always normal. Normal means perpendicular to the surface. The force that F is exerted normal to the surface, that is nothing but your pressure. Okay. So if you write down if F is the total force distributed over the area A, then the intensity of pressure represented by P upon A. Then the intensity of pressure, it is represented by P upon A. But if the force is varying, if the force is not uniformly distributed, the force is not uniformly distributed, then you can write down the pressure is equal to dF upon dA. So df is the force exerted on the small area. Is the force exerted on the small area. Small area is the df of the force exerted on the small area. Because if the intensity of pressure or force is changing, then the pressure also changing with respect to that. That's why df is nothing but dA if force is not uniformly distributed. So we know that we are measuring the stress in Newton per meter square. The force is nothing but in Newton and area in meter square. So pressure is also measured in Newton per meter square. So the SI unit of pressure is Newton per meter square, and if you go for MPS system, it is kgf per meter square. kgf per meter square. Okay, the pressure variation. Now we will learn the concept of pressure. To learn the concept of pressure, we will consider the small element of fluid. एक छोटा सा हिस्सा, छोटा सा पार्ट हम फ्लूइड का लेंगे और we will denote that part as a cuboid. तो आप देखेंगे कि हम इसको डिनोट करेंगे एज ए क्यूबाइड. तो ये जो आप फिगर देख रहे हैं, दिस फिगर, you are looking, it is a cube having a three-dimensional figure. Okay, so this one is the cube. Okay, so this is the small part of your element of fluid. So I will say that this is the small part of element of fluid. Consider a small element of fluid for analysis of the pressure variation. Let the size of element delta x, delta y, delta z. The size of element, if you see here, it is delta x in the x direction, delta z in the z direction, and delta y in the y direction. So you can say the delta y, delta x, and delta z. Okay. So likewise, you have to consider. Okay. So no need of just you understand this, the element we have taken. So you can see here the small element having a direction delta x, delta y, delta z, and shown in the figure in the fluid at rest. In the fluid at rest, because we are studying the fluid at rest, that is the hydrostatic or fluid static. So fluid at rest we are studying. The element is in equilibrium under the action of compressive pressure forces acting on all its surfaces and the self weight. Okay. So that element, the small part of that element, if I will show here. This is the element. I'll show you in the three-dimensional element. So this element, fluid element, and we describe here delta x in x direction, delta y in y direction, and delta z in z direction. From all part of this, the pressure is there, and this pressure is called as a small element, the pressure acting from the all direction. So that is the element is in equilibrium under the action of compressive force acting on all its faces and its self weight. So self weight, if you the centroid of this figure, then this is the self weight, and self weight I will denote with the gamma, that is density of the fluid. Okay. So here, let P is the intensity of pressure at the centroid of the element through which its own weight gamma is acting its own weight delta x, gamma delta x, delta y, and delta z. acts vertically downward, where gamma is the weight density of the fluid. Where gamma is the weight density of fluid. तो आप यहाँ देखेंगे वैसे point O is nothing but the self weight at the centroid of the cuboid, and gamma is the weight density, the gamma into delta x, delta y, delta z. Okay. सेम डीएनएस का प्रॉब्लम दे रहा था तो मैंने रिस्टार्ट करके चालू किया, टाइम वेस्ट हो गया ना 25 मिनट। हाँ, यानी जब कनेक्शन हुआ तो डीएनएस का प्रॉब्लम दिया, पहले तो वो ले ही नहीं रहा है इसके बाद, आप क्या देख सकते हो। So that's why this said, sorry for disturbance. Uh, this gamma is nothing but the density of the liquid. Okay, so this tube is nothing but a small portion, and from all where there is the pressure on this fluid element. Okay, so we are studying this hydrostatic. Okay, the element in a state of rest, in the state of rest, यानी वो जुमूद की हालत में है, जुमूद की हालत में स्टेट ऑफ रेस्ट है, तो वो इक्विलिब्रियम में है। इक्विलिब्रियम में इसलिए कि चारों तरफ से उसका प्रेशर है और जो उसका वेट है वो उसको इक्विलिब्रियम में रखे हुए है, बिकॉज आवर फ्लूइड इज एट रेस्ट। ओके, तो ये आप तीनों डायमेंशनल में आप देखेंगे, एक्स डायरेक्शन, जेड डायरेक्शन, वाई डायरेक्शन, हर पार्ट से उसके ऊपर प्रेशर है और गैमा डब्ल्यू जो है सेल्फ वेट। ओके, तो अब यहाँ पर हम लोग इसका कंसेप्ट हम पढ़ेंगे, है ना। नाउ वी विल सी दैट let P is the intensity of pressure as centroid, जैसे कि हम लोगों ने देखा, through which its own weight, that is gamma, delta x, delta y, delta z, acts vertically downward, where gamma is the weight density of fluid. अब हम देखेंगे the intensity of pressure on face AEFB, that is P minus dou P by dx into dou x by 2. So here you can see this AE, this AEFB, yani this part of your element, this small element, this part of your small element, here the pressure is acting from this direction, okay, on this area, if you write down, acts on the एरिया डो वाई डो जेड, एरिया क्या है डेल्टा वाई और ये डेल्टा जेड, ये डेल्टा जेड। ओके, तो ये एक अलग ओनली वन फेस ऑफ एलिमेंट वी आर टेकिंग, दैट इज AEFB, और यहाँ पर जो एरिया है डेल्टा जेड और डेल्टा वाई पर आपका ये प्रेशर एक्ट हो रहा है। तो प्रेशर क्या है, दैट प्रेशर इफ यू राइट डाउन on the face AEFB, so it will be P minus dou P by dou x into delta x by 2 into delta y delta z. Okay, this is the area and this is the intensity of pressure on that area. Okay, so if you pressure is nothing but you can say that force of an area, but here the intensity of force, and force if you write down, force is equal to P into A, force is equal to P into A, and P is nothing but pressure force of one per unit area. So similarly, pressure acting on the DHGS, now the direction is changed, so here it is negative sign, it is not, here you can see the positive sign, and a P plus. So on this opposite face of this AEFB, opposite face is, you can see this DHGC, the intensity of pressure P plus, here the value is plus because the direction is changing the positive sign here, that's why positive direction is there. So there is positive with the P plus dou P by dou x into delta x by 2 into delta y delta z. Okay, so this is in the one direction. If you see the another phase, if you see the another phase. Okay, if I will see, check this another phase, the phase, this one phase of this elemental part. Here also the downward direction, the negative direction p minus dou p by dou y, because this is y direction. The vertical direction is the y direction. You can see here. The vertical direction is y direction. So p minus dou p dou y into delta y into delta x into z. Because here this is delta x and delta x. This area, this elemental area is delta x and delta z. और उसके अपोजिट में हम देखेंगे तो अगेन दिस ए ई डी एच और ए ई एच डी दिस पोर्शन is opposite and the pressure is P plus dou P dou y delta y by 2 into delta x into delta z. Okay. Now if you consider the third dimension, if you consider this A B C D, A B C D, this phase, and opposite to that is nothing but this phase. So A, B, C, D, if you consider, you can see this force is exerting in the positive direction P plus dou P by dou Z into delta Z by 2 into dx dy is the area here. And opposite direction में अगर हम इसको देखें, इसके opposite direction में, तो this will be the force that P minus dou P by dou Z into delta Z by 2 into dx by dy, that is the small elemental area, that is delta x and delta y. Okay, so likewise you can write down the elemental part, okay, in each direction, है ना. तो हम अगर यहाँ पर देखेंगे, अगर मैं आपको वापस से आपको यहाँ पर बताऊँ, तो अगर if I will consider this elemental part, this elemental part, okay, this elemental part A, E, A, E, F, B, तो अगर एक का मैं लिखकर बताऊं तो आपको सब समझ में आ जाएगा. तो द फोर्स इज नथिंग बट प्रेशर इनटू द प्रेशर P minus dou P by dou x into delta x by 2, because half from this side, half from this side, okay, into delta z, and height is delta y, so delta y into delta z is the area, what elemental area. Okay, this is where the phase A E F B, A E F B. अब मैं इसके अपोजिट डायरेक्शन में अगर आता हूँ तो मेरा फेस है डी एच जी सी. So I will write down phase, the positive portion, phase DHGC. I will write down the pressure P minus, dou P by dou x. Here no minus, it will be plus, right? Because it is the positive direction, so it will be plus. Okay, positive x direction. So P plus dou P by dou x into delta x by 2 into delta y by delta z. Okay, now if you consider this elemental part, BFGC, phase of element BFGC, if you consider, so here P minus dou P by dou y into dou y delta y by 2 into delta x into delta z. Similarly, phase ADHE, it will be P plus, dou P by dou y into delta y by 2 into delta x delta z, delta x, delta z. Okay. Now, if you consider this element part ADBACB. I will change the color to understand you. If you take the elemental part ADCB, it will be acting on the area delta x, delta y, delta x, delta y. So it will be AD, CE, I think so, CB, AD, ADCB, ADCB, ADCB. It is positive z direction, P plus dou P by dou z into delta z by 2, okay, into delta x, delta y. Similarly, opposite face of this equal, right? Negative z direction, that is EHGF, 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 that is nothing but P minus dou P by dou z into delta z by 2 into delta x into. So likewise, the pressure acting on is the direction. But here, if you see the pressure on the y direction, there is the acting the self weight of this element, that is gamma. Gamma into delta x, delta y, delta z. Okay. So if you come to here, you can see that uh, similarly the pressure as the element in equilibrium under the action of said forces, the algebraic sum of forces acting in any direction is 0. So it means that if your fluid element is at rest, okay, so algebraic sum of forces acting on the direction is 0. So if you write down in each direction, how many directions are there? 3D elements are there. So delta fx is equal to 0, one direction. Another direction is delta fy is equal to 0, and another direction is delta z is equal to 0. Okay. Now we'll consider the x direction only. X direction only consider. So delta fx is equal to 0 gives so P minus dou P dou x delta x by 2 into dy dz minus P minus dou P dou x into dou x by 2 delta y delta z is equal to 0 at fluid as at rest. Okay. Since you know that delta x, delta y, delta z should not be 0, it is the elemental part. They have any some dimension. It is not be 0. So therefore, dou p dou x is equal to 0. So it gives that dou p dou x is equal to 0. So it may be you can resolve this after solving you will get this dou p by dou x is equal to 0. Now we consider the vertical direction, that is delta fy, delta fy. Okay, so now you can write down the delta fy. So delta fy is p plus dou p dou y delta y by 2 delta x delta z minus p minus dou p dou y into delta y by 2 delta x delta y. Here you can see the negative gamma, the downward self weight of the fluid element with gamma delta x, delta y, and delta z. It is one more. It's there available. Okay. So if you solve this, then dp dy it will be common is equal to gamma. Here dp dy will not be 0 because here is the self weight of the element is in the downward the pressure. Okay. So the dp dy is dp dy dou p dy nothing but it is equal to gamma. After solving, this is equation number 2.4. It is given in the book. Now gamma summation of fz is equal to 0 in the z direction. So if you see the negative and positive z direction, p minus dou p dou y delta z by 2 delta x delta y minus p dou p dou z into delta z by 2 delta x by delta x delta y. So you can see here if you will get the answer dou p by dou z is equal to 0. So yani this is if you resolve p minus dou p by dou z into delta z by 2 into delta x into delta y minus p minus dou p by dou z into delta z by 2 delta x into delta y is equal to 0. So this p will be cancelled. So what it will remain? Dou p by dou z minus 2. Here also minus dou p by 2 dou z and all the terms delta x, delta y and delta z is common is equal to 0. So if we add this, since you know that delta x, delta y, delta z should not be equal to 0, therefore if you write this 2 dou p by 2 dou z is equal to 0. So the 2 will be cancelled. So dou p by dou z is equal to 0. Is equal to 0. That is what it is written here. Dou p by dou z is equal to 0. But in vertical direction, in the y direction, because the self weight of the element is there, that is self weight of element is nothing but gamma delta x delta y and delta z. So delta x, delta y, delta z, as you are removed here common, it will be common, and therefore dou p by dou z is equal to gamma in the y direction. So dou p by dou x is also 0 from the equation, but dou p by dou y it is equal to gamma, that is weight of the element acting on the dull mode in case of fluid static. In case of fluid static. Therefore, the equation 2.3, equation 2.3, yani dou p by dou x is equal to 0. It is equation 2.3, and dou p by dou z is equal to 0. This is equal to 2.5. Shows that the intensity of pressure does not vary along x and z direction. The equation 2.4, that is dou p by dou y is equal to gamma. It shows that the intensity of pressure varies in y direction only, and hence can be written as dou p by dou y is equal to gamma. Hence can be written as dp by dy is equal to gamma. Okay, so the above expression shows that the pressure increases in downward direction. The above equation shows that with respect to the head, that is y, the pressure increases in downward direction and varies directly with the weight density gamma of the fluid. In case of static, we are learning here is static, fluid is static. This is law of hydrostatic. So this is the law of hydrostatic. This law holds good for both compressible and incompressible fluid. For incompressible fluid, its weight density is constant by integration the equation dou p integration of delta p and gamma delta y. If you write the P2 integration P1 to P2. So you can write down P2 minus P1 is equal to gamma Y2 minus Y1. Okay, this is the concept of pressure. This equation is nothing but the law of hydrostatic. This this is nothing but law of hydrostatic. It is also nothing but the concept of pressure. The concept of ओके आई होप सो कि आपको कंसेप्ट ऑफ प्रेशर को समझ में आ गया होगा हमारा जो डिस्टर्बेंस हो रहा है उसके लिए एक्स्ट्रा क्लास अगर ज़रूरत पड़ी तो आई विल टेक अदरवाइज ओके सो we will stop here. We will have another class. If there is no another class, we will continue. I'm sorry for that. Due to the internet connectivity, our lecture was disturbed. I came college 8:30 to manage to avoid the delay, but it's up to the God. Thank you for joining.